I think that was most of the work. The picture's not too hard. But there was one other thing we could have done. There was a different way we could have gone about it. And I suggest it might have been simpler. The first thing you said, what was the very, very, very first step you suggested to me after I wrote down the question? The first thing you told me to do was differentiate. That's not a bad idea. It worked out, okay? Is there anything we could have done before we differentiated to make any of this easier? This particular graph they've given us, right? It's not just any graph. You have some tools to work with this. Do you recognize it? Yeah. You could have used auxiliary angle with this, couldn't you? Now, you didn't have to. It worked, okay? Would it work out any easier if we did auxiliary angle? Let me get some space. Would it have been easier? I just posed the question to you. What does your instinct say? If you had to guess. Instinct might say yes because auxiliary angle turns two functions into one. That's generally a better thing to work with, right? What is the auxiliary angle for this? This is what you've got. Think back. Think. You've got four forms to choose from. Okay? In this particular one, two of them are better than the other two. Which ones would you choose? You could choose. The way I look at it is cos is first. Cos is first. So I would choose cos, right? And there's a plus here. The expansion for cos that gives me a plus is minus. I could do that. That would work. However, as you notice, when you're adding two things, it doesn't matter what order you add them in, right? So if sine is first, then I would say sine. And the expansion for sine that gives me a plus here is x plus alpha. Okay? So either is fine. You'll still get an acute angle for either of those. Let's go with this one. Okay, can you remember? How did we get r? Where does r come from? It is equal to 2, but why? Where does that number just... Where does it come from? It comes from the square root of a squared plus b squared, doesn't it? Yeah, okay. So r is going to be equal to 2 in this case. How did I get alpha? How do I do alpha? I can say tan alpha is equal to... Which one? Which one? I'm looking at this, remember? Now, by the way, that's fine, okay? But you have to be careful. I can only use tan alpha because I've chosen the right form, right? When can you not use tan alpha? Or maybe I should say, when do you have to be more careful about tan alpha? Under what circumstances? Do you remember? If they told you, for instance, and the question can, if they told you to put it into this form, what's going to happen to alpha? This to turn into that, alpha's not going to be acute anymore. That's kind of why we chose these two forms, because it gives you a nice small value for alpha. But here, you lose the fact that is your angle acute or obtuse or reflex? What is it? Tan doesn't tell you, okay? There's not enough information, because tan being positive, you could be in this one or this one. You don't know, right? So if I did want to know which quadrant it's in without a shadow of a doubt, what would I have to do? I can't use tan. What do I do? You've got to go back to this expansion. You've got to know it for sine and for cos. If you know the sign of both of them, then you'll be able to tell unambiguously which quadrant you'll be in. Anyway, don't want to turn this into a lesson on auxiliary angle, because we're trying to do calculus here. What's the angle that matches up with this? This is pi on 6, isn't it? Okay, right. So therefore, y is 2 sine x plus pi on 6. So what's the first derivative? 2 cos. Now, this is chain rule, but it just so happens that the derivative of the inside function is 1. That's nice. Was that easier to differentiate? I think so. Second derivative, which, by the way, is exactly what you ought to expect, because we kind of concluded that already, didn't we? Just saying. Okay. Now, if we were to find the stationary points of a guy like this, you compare it. I'm not going to do it on the board because I think you know how to do this, but you compare that to this. What do you reckon? I don't know, maybe you would prefer it like that because then you don't have to muck around with the domain and be careful with that kind of thing. Same with this. I kind of like it though. We didn't tell you to do auxiliary angle, which is why you marched straight through there and it was fine, okay? But it's in your interest sometimes to choose to do so because it will simplify the question for you. Okay, make your arithmetic easier, make the differentiation easier as well, all that kind of thing, okay? So just be mindful as you go through these questions, they're not necessarily going to say, use general solution for this, but it might be the best way to go. It might be the best tool in your toolbox, okay?